thank you everyone for turning up. This is amazing. So many people here. You should all be in class doing some stuff. So I should explain a little bit about me, really, because I'm not normal. So my undergraduate degree is geography and geology. And then I did a PhD in geology at Bristol University, same time as Dr. Francis over here, alongside. She was studying carbonates and I was studying active tectonics, active faulting, landscape evolution. And then in 1990 I finished that and I started lecturing geology at university. And then in 2002 I had a midlife crisis and I ran away from university because I wanted to get geology on television. And I'll talk a little bit more about that change later, but in 2002 I did that, and then I did get some television, started working with the BBC, started making documentaries, and then I came back into university. I didn't want to be a television presenter, I wanted to be a geologist doing geology programs. So I came back into university, Plymouth University in southern England, which is the surfing capital of England. And really I've been there for the last 12 years or so, the last 5 of which has been as Professor of Geoscience and Communication. So what I do, I mean I still teach and research and all the normal academic things, but the point of the chair in Geoscience and Communications, my job is to do this, is to talk to people about geoscience, earth science, the planet, why it's important, and why also it's important for society and for the public to know. So many of my talks are to the public or to industry or to anyone who will listen. So maybe I should explain. My name is Iain. It's very strange, it's a Scottish for John. Yeah. So it's Juan. Maybe I should be Juan. What, in Brazilian, what would it be? Joan? Joan. I'm Joan Stewart. That is Iain, so obrigado. And I'm now director of the Sustainable Earth Institute, and this is relevant because what that is an attempt to be an interdisciplinary research organisation with geoscience at the centre, but with a whole lot of disciplines around it, including social science disciplines, and the relevance of that will become clear later on. So I'm going to try and remind myself to talk slowly for you, because my accent is probably quite difficult, but I'll get faster. It's natural. So, I'm interested in talking to the public because it seems to me that what the geoscience, there are 2 sides to geoscience. The top is the idea that geoscience understands how the planet works. It understands its rhythms, its thresholds. So if you're interested in things like climate change and protecting the planet, then you should speak to a geoscientist, because a geoscientist understands our planet. So that is about Earth stewardship and protecting the future. This is the other side of Earth science, which is that Earth science finds stuff, finds things that are useful. This is gold, but it could be metals of any kind, it could be oil and gas. Geologists are very good at going out and getting stuff that people need. And people show no signs of not wanting to consume materials for phones, or for energy, or for everything. But this is about exploiting the Earth. And so geologists have this kind of slightly schizophrenic, two-minded, we are people who are in charge of protecting the planet, we are also the people who exploit the planet. And I think that's really important for us to realise, is that we provide a service, and that many in this room will prefer this side, some will prefer that side, but actually all of us are somewhere in the middle. These are both realities. And so the important thing is trying to communicate to the public that geology is really critical. It's critical for most of the big issues that face society in the 21st century. In fact, arguably, with increasing population, most of the key issues that are going to limit society are related to the planet. As I say, where we're going to get our materials from, where we're going to get our energy from, how we're going to build our infrastructure, land in terms of land use changes, but also protecting land, for example, in terms of soil fertility, etc. Water, critical one, particularly in relation to the story of climate and the changing climate that we know. How we deal with the environmental legacies of some of these, energy and minerals, to do with human health, so geo-health. Something that's very big, particularly in Brazil, and I was hearing more about it earlier, is the idea of geo-heritage, that the geology is our past. It's part of who we are, and therefore that has an economic, increasingly an economic increase because of geotourism, for example, geoparks, etc. Patron of the geopark in southwest England, English Riviera. And then, hang on. And then also, this is mainly what I do. My own research is in this area, hazards. So this is earthquakes in Turkey, which I work on, but the idea that there are natural threats that have to be communicated. In all of these areas, geoscience could be really important for society. But actually, often what we find is that geologists, generally, as a rule, don't get involved in ideas to do with sustainable development. That is seen as something that geography does, or biology does, or environmental science does. Geology is kind of this science that doesn't just understand, it's very technical. To my mind, geology has got a crucial role to play. But one of the key things holding it back is our ability to communicate to the public about what we do. Here is one of the problems. It says here 50 shades of grey. This is what the public thinks geology is. It's stones. When I left university and went and tried to get television programs, I would go to TV companies and they would say, so you want to do a program on geology? It's fascinating, really interesting. And then for 5 minutes they would talk to me about archaeology. And I would say, no, I don't mean. And they say, well, explain. And I would explain. And then they said, so you want to make a film about stones? That is our world. That is our world. You know this. The reason you're laughing is because you've been in that situation. Explaining to people that you study stones. And they look at you like you're some sad individual. But we know it's not about stones. But this is the problem, is the perception that this is just layers of grey. Uninteresting. In fact, these are mudstones. There's nothing in them, there's no fossils in them. They're the most boring rocks in the world. The other problem we have is that we deal with time in a way that no other science deals with time. So our currency is to talk about, not long ago, 10 million years. And people look at us as if we're stupid. 10 million years is a huge amount of time. Of course, not for us if you're studying 2.5 billion-year-old banded iron formation. So we are time travelers. We go back into time. And in fact, when we're looking at the landscape of the world, we are looking at it with a different lens on. A lens that we can imagine. Completely different world, where an ocean lies in an area that's now semi-arid or something. That is extraordinary. That's just extraordinary rewiring of our brain that is happening over the course of the years that you're involved in now. I have a colleague who, we go on the very first year trip to the south coast, the Jurassic coast of England. And in the very first day of the very first field trip, he said, look at that cliff. Look at it. And he gets him to look at it for a few minutes, and he says, right, that is the last time you'll ever see a cliff like that. Because you're now going to see it with a geologist's eye, and you'll see completely different things. You'll see strata, you'll see fossils, you'll see everything. You will not see a cliff of rock. But normal people, everyone else, sees a cliff of rock. The other thing that, of course, we do is we go down. Our world is down there. It's in the subsurface. Again, most normal people don't even think about the subsurface. It doesn't exist. So that when we talk about things that happen down at high temperatures and high pressures, that doesn't compute for most people. So what I'm trying to get at is that through the course of your 3-4 years as learning to be a geologist, your brain is changing. And you're becoming trained to look at the world in a completely unique way, a way that no other science does it. Physics, chemistry, biology doesn't do this in the same way. That makes you tremendously important in terms of the way you look at the world, but it also makes you different from everyone else. And that creates a problem when you want to communicate, because you're different. So, one of the things I just want to talk about is this business about when I started to do television and being confronted with what other people thought geology was, I had to completely rethink my whole subject, because I had to see it from the outside. This is Glasgow University, where I went to for a couple of years while I got television off the ground between 2002 and 2004. And a few years ago, they did a survey of the students coming to the university to see if they liked it. And they asked them one question. They said, who digs for dinosaurs? And this is the survey results. 65% said archaeologists dig for dinosaurs. Only 27%, nearly just over a quarter, said paleontologists. 5% said Ross from Friends. And that's the clue. It's television. Because the point is, on television, archaeologists are far more prominent than paleontologists. After archaeologists dig into the ground, into the past, so yeah, that's pretty much the same, which is one of the reasons that we think of, people can mistake archaeology for geology. The interesting thing though is, if you're thinking about which part of geology is most in the public glare, public view, it's dinosaur paleontologists. So, maybe alongside volcanologists, but the point is that even the most prominent geologists in the public are still confused with other scientists from another discipline. So we have a profile problem with the public about what we do. That's quite clear. So the reason that I left academia temporarily was because I thought that television was the most important way to reach a much wider audience. So really from 2004 all the way through around to, well, it's 2016 now, I've been working with BBC Science, making a series of documentaries. All of them in one way or another about geology, the Earth, the planet. In the early years, this was about just trying to present the planet in a different way. It was presented like a little bit of mixture of history and archaeology and culture and travel. So my first series, Journeys from the Centre of Earth, I wasn't allowed to say any rock names. Well, I could say granite and I could say limestone. I wasn't allowed to say any other rocks. I wasn't allowed to go into any quarries, because that was geology. So we did a lot through popular culture. The series there was about architecture, food, water, belief, and so there were topics that ordinary people liked. They weren't about rocks. But each time you kind of picked up a story, you turned it over, rocks or geology were underneath it. So that was the key. And then geology became a little bit more common, so we could actually have programs like Earth, Power of the Planet, that just explains how the planet works and how Earth made us, which is really about kind of the Anthropocene, really, about human activity in the planet. And increasingly, more and more, that program, Men of Rock, is just about geology. It's about geologists, actually, the history of geology. It's not a program I could have done in 2004. So they can become ever more complicated. And then, interestingly, in recent times, it's about energy. This is about fracking. This is about oil. There's a program on climate change just in there. So that's kind of what I've been doing, is trying to present the planet always in a slightly different way for a different audience. And the reason that it's worked is because geology works really well on television, actually. Some obvious reasons for that. It's very visual, especially with volcanoes, etc. We've got fossils and life. And geology is, the funny thing about geology is geologists often feel really inferior to proper scientists. You know, if you're a clever person, you'll do physics, or chemistry, or maybe biology. If you're not, you'll end up falling down into geology. It's this derivative science. But actually the point is that geology is a really hard science because it takes all of the sciences and combines them and presents it, uses maths, physics, biology. At its core, it's a historical science. So time marches through geology. And in that sense, the historical sciences are human history, archaeology and paleontology, geology and cosmology. This is what historians refer to as big history. In other words, that history starts now and goes all the way back to the Big Bang. That is our past. That is our human past, all of that. And the reason why it's very powerful is that people are intrinsically interested in their past, their own past, and their history. So geology becomes part of that. So it's actually quite easy to sell, along with everything else, is that we've got this amazing story to tell about how the planet evolved. We're just going through the museum next door, you just see that. The stories just come through. So geology is pretty easy in comparison to some of the other sciences like physics, chemistry, and biology. This is a list of, I should explain, Horizon is on British television and it's the main science documentary strand. So they do serious science documentaries. And this is a list of the top rated horizons between 2000 and 2011, so a decade. And what you'll see is the top one, Mystery of the Persian Mummy, is an archaeology one. But the second one, Mega Tsunami, and the third one, Supervolcanoes, are both Earth science. And then you've got Extreme Dinosaurs. This is about a super twister here. Dinosaur that filled the world, what really killed the dinosaurs, so you get the idea. Dinosaurs are good. Averting Armageddon, that's about a meteor impact. The next megaquake, earthquake, storms. So you get the other idea. Disasters are good. So geology on the television becomes disasters and dinosaurs. Which isn't quite what you're learning in the classroom. And you can be depressed about that and think, oh, my really interesting stuff. Why don't you make programs about high-grade metamorphic rocks or something? The point is to learn why it is that those programs work. And it's because they've got drama and everything else. So actually, if you look at this as a pie chart of the top 50, that pie there, that blue one, the biggest one by far, is Earth science. And actually, there's climate in there as well, which could have been lumped in together. So geology does, on British television, does better than most other science. If you look down this list, it's very hard to find physics. There's one. A freak wave, it's kind of not really physics, but I just gave it to physics. Chemistry, vitamins, it's not really chemistry. Biology, the boy with no penis, turns out to be neuroscience, actually. I should change that. So, but I felt sorry for biology. So the big sciences that dominate the academic world don't do especially well, because they don't translate onto television especially well. In fact, if you've seen Brian Cox's work on Wonders of the Universe, Wonders of the Solar System, he invariably stands behind an erupting volcano or a waterfall to explain some physics concept, because most science is very abstract. Our science is we come up and we say, see this rock? It looks like a sand. We call it a sandstone. That's not complicated. People can see that, so it becomes very immediate. What is interesting here is that during that early period, you'll see that most of these are from 2000 to 2004, even though the list was to 2011. And that was a time when Horizon was very, very successful. It was very successful because of one thing, that it took its science producers, its science directors, and it sent them on a Hollywood script writing course by this guy, Robert McKee. So he does film script writing tutorials around the world, and he uses Hollywood blockbusters to illustrate that there's only a few ways of telling a story. Since the beginning of time, since people started telling stories, stories have been told in broadly the same set of ways. And he illustrates it with everything from Independence Day through to Titanic or whatever. And his key thing is that every story needs to start with an exciting, in other words, something that get you going, a hook, an inciting incident here. And the first act sets that up, sets up a problem, a challenge. The second act then is the journey through that challenge, full of trials and, you know, difficult situations to be overcome, either of an individual or a group. And then at the end of the act too, there is what they call a false resolution. So it's a moment where you think you've come to the end, and then you haven't. So a classic 3-act structure, boy sitting in classroom in school, very bored. Suddenly, door opens, new girl comes in that's just moved into the neighbourhood and just come to the school. He falls in love. You think, oh my goodness, I love this person. So the next part is the journey to after this girl, and it goes through all different types, and you know what's going to happen. They get together, and you think it's the end, and then boy screws up. Boy messes up somehow. It's a confusing thing. Girl goes away, and the last few minutes of trying to get the girl back, or whatever. You can imagine these stories. But you end up with the Act 3, everything together. So that was what Horizon did. It fitted science into storytelling in a way that really hadn't been done before, and it was very successful. To illustrate that, I thought I could show you a little clip. So I've got a clip of, well, you can have a choice actually. 3 clips. I've either got something from a mega tsunami, which is a story of La Palma volcano collapsing into the sea and creating a huge tsunami that wipes out Florida. Or a little clip from a super volcano about Yellowstone erupting and creating mayhem. Or I've got a clip from a story about mathematics, an obscure aspect of mathematics that only a handful of mathematicians in the world understand. So who would like to hear the one about mega tsunami? Put your hands up if you'd like to see the little clip. It's only a couple of minutes. Mega tsunami, okay. Super volcano, okay. The obscure mathematics bit. All right, let's show the mathematics. So you need to. It's quiet at the start, so I think there is sound. Sound? This might work. It'd be interesting to know if this works just visually as well as audibly. So our visual bits will work, that's good. This will be a real test of how good Horizon is. It's better with sound, I have to say. Do you think we'll get it, or will I just continue for no sound? So, what was interesting about that was 2 things. You all laughed at the time. Oops. You all laughed at the bit where you saw the messy office. And then, did anyone notice what happened at the end of the clip? Something happened to the mathematician. Hmm?
He dies.
No, I mean, at the end of that, he didn't die. What did he do right at the end of that clip? He didn't laugh. It was kind of a laugh, but it wasn't really a laugh. What was it?
Crying.
He actually cried. He started to cry. And that Horizon was one of the most successful Horizons. And the reason it was successful is because what happens is after that, you want to know his story. You want to know why a mathematician is crying about a bit of maths, because that doesn't compute, really. And science isn't very good about being emotional. But one of the things it does is it tells a story. And really, this is a Fermat's last theorem, quite a famous story. But really, the way that it works is because it makes science an emotional journey. And we don't tend to do that in science. We tend to keep emotion out of it. So, one of the interesting things then is telly is obviously really important. So this is from where people get their information from. This is American data, but it's pretty much the same anywhere, really. Current news, television. So all the way through from 2001 to 2010, television dominates. If you're interested in what the news is, you turn the television on. And the internet is rising up, and the newspapers are dripping down, but by and large it's television. This is where people get their general science and technology from. So when I left academia in 2002, it was there. And I've gone on a downward slope ever since. In fact, the internet has been rising all the way through that. So actually, I've made a terrible strategic mistake. I've got onto the wrong medium. I should have got onto the internet. Because actually, if you look at specific issues like climate change or GM or any of these, fracking, it is always the internet. It always has been. And you know this. If you're wanting to know a bit of information, you go into the internet. So you Google it or whatever straight away. So I say this because what it means is that the very traditional medium that I get into is now kind of dead. It's gone on to another world. And for you guys, learning to think about communication, I wouldn't be thinking about, oh, I want to get on and make a major television series with a major broadcaster. It's very unlikely to happen, but actually it's not as effective anymore. Learning how to use the internet is one of the biggest challenges. And what's great is that you guys are what's called digital natives. You've grown up with the internet. You're very familiar with it in a way that we're still kind of know it. Lots of social media that I use, I don't really understand, but you guys do. So thinking about how you communicate using this is going to be really important. So I just want to highlight a few things that highlight that geocommunication is more than simply making television programs, and even for me. So one thing is increasingly something like YouTube. So increasingly many of the things I do, I make little programs, little short things for YouTube. This is one I did for the Natural Environment Research Council on how earthquakes work. And that gets used in schools, and it gets used, and of course the point is for YouTube, you can see it anywhere in the world. Someone in a little village in Nepal can wire up their thing. If they can understand English, they can watch this video. Amazing, that is extraordinary. So you can make your own YouTube. Some of you will do anyway. Get a camera, film something, 30 minutes later it's on YouTube for the whole world to see. That is an incredibly powerful resource. This is one I did the other, oh yeah.
Yes, sorry, are there other videos?
There are, yeah.
Yes, I will change the cable now.
Okay, okay. So the other thing is, we use psychology. So some of the interesting things is that YouTube video I put up with my PhD student Hazel, who's working with cognitive psychology, trying to understand the subsurface, what people think of the subsurface. So we just published a paper, we put it out on YouTube, you can start to do that. This is another of my PhD students, this is Johanna. She's an anthropologist, a visual anthropologist. We're studying the communication of seismic hazard in Istanbul. It's a huge issue. Istanbul in Turkey, it's got a big earthquake problem. Everyone knows it, but no one's doing anything about it. No people in the communities that are at risk aren't changing it. So the interesting thing here is to be working with communities. This is geoscientists working with communities. You'll see there's a filmmaker there. Johanna's on sound. We're creating kind of community-based films to try to talk to people about how they could, why they should take risks, adjust to the idea of seismic risks. So these are working with local communities to make films for them. It's a very different type of thing to work